you know how to find out squares of numbers, decimal numbers, fractions. Come on, find out the square of this number. Well, it is a large number. Well, we can say it is 51,112. Find out the square of this number. Now you will think this is so boring. You have to first multiply 51,112 with itself and then write the answer. Okay, I give you a hint. Suppose I tell you 51111, that is 51,111, the number just before 51,112. The square of this number is this. Okay, I give you the hint. Now with this number, can you find out the square of this number? Well, again you will be confused. Like if I give you the square of 3, can you find out the square of 4? It is a similar kind of question. But then how is 4 square related to 3 square? Similarly, how is this square related to this? Well, there is a connection. Let me tell you that. Okay, now forget those numbers and look at the list of these squares. You can see 1 square 1, 2 square 4. Similarly, we have listed down the squares of 1 to 10. That is 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100 respectively. Now, if I tell you to look at the numbers between the first two squares, that is 1 and 4. Which are the two numbers that come between 1 and 4? Well, 2 and 3. Right? Similarly, the numbers between 4 and 9? Well, these are small numbers, so you can find out the difference between such numbers. So, which are the numbers that come between 4 and 9? 5, 6, 7, 8. Well, now there is a property of these numbers. Can you tell me what are these properties? Well, look at these. 2 and 3. How many numbers between 1 and 4? 2. Look at these. 1, 2, 3, 4. How many numbers between 4 and 9? 4. So there is a property that comes out from these numbers. Well, multiplying 2 with this gives us the number of digits between 1 and 4. Well, difficult to understand? Let's look at all the numbers first. Look, the numbers between 9 and 16, 16 and 25, 25 and 36, I have listed them all. Now looking at all these numbers, you will see that if I multiply 2 with the numbers over here, one by one, I get the number of digits that will be between their squares. Check out all. Let's do that one by one. 2 into 1 gives us 2. So 2 numbers between 1 square and 2 square. Similarly, 2 into 2 gives us 4. That means 4 numbers between 2 and 3. Again, 2 into 3. That means 6. So there are 6 numbers between 3 and 4. 1, 2, 3, 4, 5, 6. Check the last two ones. 2 into 6. That is what? 12. Check whether there are 12 numbers between 6 and 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers between the squares of 6 and 7. So if we take this number, say as n, then 2 multiplied with n will give us the numbers between n and n plus 1 square. We can say that there are 2n non-perfect square numbers. Why non-perfect square numbers? Because these numbers are non-perfect squares, only they are perfect square numbers. Between the squares of the numbers n and n plus 1. Again I repeat, say if this 6 is n, then 7 will be what? N plus 1. So between n square and n plus 1 square, we have how many numbers? 6 into 2, that is 12 numbers. So 2n numbers are present in between n square and n plus 1 whole square. So this is the relationship you can see we got down from this pattern of numbers. So there are 2n non-perfect square numbers between the squares of n and n plus 1. So now you're familiar with this relationship. Now, if I ask you how many natural numbers lie between 9 square and 10 square? Well, you can go and count. Say 9 square is 81 and 10 square is 100. You can start counting and tell me the answer. But that is a very long process. Using this, you can tell me the answer of this. Here take 9 as n and 10 will be what? N plus 1. N is 9 and n plus 1 is 10. And we know that between the squares of these numbers, we have 2n numbers. So, 2 into n will give me the answer. Here n is 9. So, replace n with 9. We get 18. So, I can say that there are 2n, that is 18 numbers between 9 square and 10 square, even without looking at the list of numbers present between them. Well, check for yourself. Count the numbers between 81 and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, excluding 81 and 100, so the numbers between them are 18. So, you are clear with this? This formula or this relationship is true. Now, one more thing. Suppose I know n square, that is say 81, and I want to know what is n plus 1 whole square. So, what can I do? If I know n square and I want to know n plus 1 whole square, what do I need to do? See, I know 81, that is 9 square. And to calculate, say 10 square, I do not know the answer of 10 square. How many numbers should I add to this 9 square to get the 10 square? Let me see. Again, start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So adding 19 numbers to this n square will give me n plus 1 whole square. Till here it was 2n. We had already counted. Now adding one more, that is 19 numbers will give me 10 square. So I can say that one more relationship we get, or you can say even rearranging them, we can say that if we know n square and I want to derive n plus 1 square, I can add 2n plus 1 numbers to get n plus 1 whole square. Well, this you saw from this example. Well, let me see whether this holds true or not. If this is true, then n plus 1 whole square minus n square should give me 2n plus 1. Let's see. Let's see what do we get. With a plus b whole square, that is a square plus 2ab plus b square, expand this. N square minus n square gets cancelled. 2 into n into 1 gives me 2n plus 1 square gives me plus 1. So we get 2n plus 1. So you can see that n plus 1 whole square minus n square gives me this. So I can say that this added with this will give me this result. Or adding 2n plus 1 numbers to n square will give us n plus 1 whole square. So if you know a square of a number and you want to find out the square of the next consecutive number, you can just add 2n plus 1. So now with this relationship you can find out the square of this number. Here what is n? N is the first number. And this is what? Just n plus 1. So n square is this. This is n square. And what we have to find out is n plus 1 whole square. And we know that if we want to find out n plus 1 whole square with the help of n square, we just need to add 2n plus 1. This whole thing will give us n plus 1 whole square. So n square we already know. N plus 1 square is what we have to find out. And adding 2n plus 1 to n square will give us n plus 1 whole square. So first of all, let's find out 2n plus 1. What will we get? 2 into n here is 51111 plus 1. That is what we have to do. So finding 2 into 51111 is very easy. Well, finding this was very easy. Just add 1 with it. We get this. So we know now n square, that is this. We know now 2n plus 1, that we have already calculated, 102223. And now we have to find out n plus 1 whole square. So instead of multiplying this with itself and creating such a big multiplication table, just add n square with 2n plus 1 to find out n plus 1 whole square. So n square plus 2n plus 1 will give us n plus 1 whole square. Just substitute the values. N square we get from this. Plus 2n plus 1 we had already calculated. So adding 2n plus 1 to this huge number, we get the answer of 51112 whole square. So you saw, instead of creating such a big multiplication, just find out the difference between n square and n plus 1 square, that is 2n plus 1. Just calculate 2n plus 1 and add that number with the square already given to you to find out n plus 1 whole square.